Question 6. Two boys in a canoe toss a baseball back and forth. What effect will this have on the canoe? This question challenges our understanding on the concept of conservation of momentum. For simplicity, I will consider the canoe is at rest initially, meaning the momentum is 0. So when the person on the left tosses the ball, say to the right, he will provide the ball with a momentum of mv in that direction. In order to conserve the total momentum, since both two guys are assumed to be staying still on the canoe, the only way is that the canoe itself provides a counter momentum, big M v prime, in the opposite direction. This will result in the change of the velocity of the canoe from 0 to some v prime. And this also means that the canoe will start moving to the left. Then, at the time when the person on the right caught the ball, the velocity of the ball becomes 0, meaning there is a change of momentum mv in the opposite direction, which is in the left direction. In response to the change, the canoe now needs to produce a counter momentum of mv prime, equal magnitude, but this time round in the opposite direction, which is in the right direction. So at this point of time, the canoe will be back to the state of 0 velocity until the person on the right starts tossing the ball. And when the person on the right tosses the ball, similar things happen except the movement of the canoe is reversed. By repeating the above process, we can imagine that the canoe will keep moving back and forth in order to counter the momentum of the ball. One more thing to consider is how does the canoe move? Is it drifting away or is it just oscillating around its original position? To answer this, let's assume the mass of the canoe plus the two guys to be a times the mass of the ball. We can show that the velocity of the canoe is negative 1 over a times the distance between the two guys over the time to reach the other side. Since the time to reach the other side is the same as the time when the canoe changes its momentum, the distance the canoe has traveled can be shown to be only dependent on the distance traveled by the ball. And in this case, since the two guys are staying still at their position, the distance traveled by the ball is kept constant all the time. And this also implies that the distance traveled by the canoe is also constant. This further means that no matter how hard or how fast you throw the ball, the distance traveled by the canoe is always the same. This also means that the canoe is oscillating back and forth. And so, the correct answer is D.